So this question says p of x is 2x to the fourth minus 13x cubed plus 7x squared plus 37x plus 15. They want you to show that c equals -1 and c equals 3 or zeros. All right. And however that question is structured in web design, I didn't ask you to type some stuff in, like explain yourself. You don't have to do that. I'm not going to grade that part, but there is a part on there that asks you to type in some values. Okay, so do that part. The other part, then I'll have to go back into everybody's and award points for that, but it's not like this here. Okay, it says find all other zeros. Okay, if you can find all the other zeros, then you've told me that you have shown that -1 and 3 are in fact zeros. Does that make sense? Okay, and we'll go through this and kind of explain that in this question. All right, so the first thing we do is we're going to take one of these C values, all right, and remember C is always what goes in your box, right? When we do synthetic division, so a pure -1, okay? Other ways that they might ask this is they might, instead of saying C, they might say, check to see if x minus 1 is a factor. Then you have to develop the C to be -1. Does that make sense, everybody? Okay. So I put my -1 in there. Write my coefficients down: 2, -13, 7, 37, and 15. Right. Make sure that you are putting in placeholders if necessary, so everything lines up correctly. All right, bring your 2 down. Multiply by -1, I get -2. Add straight down, gives me -15. Multiply, add straight down, gives me, 22? Gives me -22 when I multiply by -1. Add straight down, gives me -15. Or positive 15, positive 15. Add straight down, and you get a 0, right? All right, so what we talked about yesterday, the remainder theorem says if that's a 0, okay, I guess the remainder theorem and the factor theorem kind of together, when that's a 0, x minus the C term that you had, so x minus -1, we'll probably write that as x plus 1, right? So x plus 1 is a factor, okay? -1 is a 0. Okay, so here's what this kind of leads to. It's not necessary that you write this part down. I'm just going to kind of provide some instruction here. I hope you recognize something here. If I go x plus 1 as a factor, then this is my other factor to get back to 2x to the fourth minus 13x cubed plus 7x squared plus 37x plus 15, right? So I'm going, if this was x to the fourth there, this was an x to the first out here, right? What is x to the fourth divided by x to the first? X to the third. So it tells me that's x to the third. I always want to figure that out so that I can rewrite this as 2x cubed minus then 15x squared plus 22x plus 15. Okay? So that is what p of x now looks like after we figured out that -1 is a 0 and x plus 1 is a factor, right? That makes sense, everybody? Okay? You multiply that out. The next part of the question says, see if 3 is a 0. All right? And at this stage, there's really 2 things you can do. I'm going to do this kind of the long way. Don't write this down, maybe. Okay? Because this is the long way. And it really doesn't provide much insight for finding those additional 2 solutions that they're asking for. Okay? But if all I was interested in is seeing if these were zeros, I could start back at the beginning. Okay? Put a 3 up here now. Do my synthetic division. 2, 6, -7, -21, negative 14, negative 42, negative 5, negative 15, 0, right? So what that tells me is that P of x, with 3 being a 0, would factor this way, x minus 3, and then 2x cubed minus 7x squared minus 14x minus 5. Okay? If I FOIL this black one out, I get back to the same P of x. If I FOIL the blue one out, I get back up to the same P of x. Does that make sense? But because I got a 0 right here this second time with 3, okay, that means if I would have just looked at this here, okay, because x plus 1 is a factor and x minus 3 is also a factor, that means this x minus 3 would have also divided this black thing right here. Okay, so instead of doing it that way, let's do it this way. Let's go back to this stage right there. Okay, and when we have that information written down, we have found 1, 0. I'm going to start the entire process over again with the new 0, the new c term, but I'm not going to start with the original P of x. Okay, because we have just shown that x plus 1 is a 0, or is a factor, okay? And we also have shown that 3 was a 0, right? We did that work? So that means that x plus 1 and x minus 3 are both going to divide this polynomial. Well, I've already shown that how x plus 1 divides it. Now the idea is x minus 3 is going to divide what's left over here. Does that make sense to everybody? So basically the practice is, once you've found a 0, kind of just start the whole process over with that other c term. Okay, now I usually don't, because I don't like to write as much, so I just kind of start back up with this line here. But if you want to kind of restart the whole process and write 2, minus 5, 22, and 15 again, just to organize your work maybe a little bit better, you can. But I'm going to bring my 2 down. Multiply by 3 gives me 6. Bring down my negative 7, right? Multiply gives me negative 21. What have I done? 6, 2, 6. Man. Come on, Zach. So 3 times negative 9 is negative 27. Now it gives me negative 5. Now it gives me negative 15. And now you see that additional 0, right? Okay. So what that tells us then is that that original P of x has this as a 0 and that as a 0. So if x minus 1 was a 0, then x plus 1 is a factor, right? If 3 is a 0, then x minus 3 is a factor. So I'm going to write x plus 1, x minus 3, and now this was x to the 4th. You divided it by x to the 1st, got you x cubed. Then you took x cubed, divided by x to the 1st, and you get x squared, right? Each kind of new line of the synthetic division will depreciate my polynomial by 1 degree. So I know that this remaining line here is 2x squared minus 9x minus 5. That P of x is identical in regards to what it does. It obviously looks different, but it does the exact same thing. It is the same polynomial as what we started with. Okay. However, we can go further because x plus 1 and x minus 3, those are linear factors. They're exponents of 1, right? 2x squared minus 9x minus 5, that's a quadratic factor. Can we factor a quadratic from Algebra 2? Do we know how to do that? So I'm going to do some work for that. I'm going to take my 2x squared minus 9x minus 5, take it to the side, do some scratch work with it. Okay, I'm going to factor it. Well, first thing I would try is to see if everything has a GCF. See if I take a 2 out of everything. Can't. So the next thing I try is A times C method. So multiply both 2 and negative 5, you get negative 10. Now, what are two numbers I multiply together to give me negative 10, but add to give me negative 9? Negative 10 and positive 1. Okay? So now, the A times C method says, rewrite your quadratic, but instead of writing it as negative 9, write it as a sum of those two things. So I'm going to rewrite this as 2x squared minus 10x plus 1x minus 5. Okay? The negative 10x plus 1x still gives you negative 9x, right? Now, the whole reason the A times C method, why we're trying to do that, is because we want to group these things, right? We want to factor by grouping, actually. What comes out, what's the GCF in this first group? 2x. So then I'm left with x minus 5. What's the GCF over here? Positive 1, right? So x minus 5. So this quadratic breaks down to 2x plus 1 and x minus 5, right? That is what that quadratic up there simplifies to. Breaks down to linear factors. Now, I'm going to bring my x minus 3 down. I'm going to bring my x plus 1 down. And now I have p of x fully factored. Okay? And now you know, let's think about graphing this thing. It was x to the 4th, right? A was positive, so you know you're in behavior, correct? Okay? That's that goes to positive 3, y is going to go positive 3, that goes to negative 3, and y is going to go positive 3. Do you know you have a 0 at negative 1, or an x-intercept at negative 1? You have an x-intercept at positive 3. You have an x-intercept right there at negative 1/2, right? Okay? And there you have an x-intercept at positive 5. Okay? You also know, because it was x to the 4th, you have the potential of having 3 turning points. Take 4 minus 1. Your n value, your largest exponent, minus 1, tells you the total number, the maximum number of extreme values you can have. Okay? So you can have a maximum of 3 maximums and minimums. Okay? Or maybe a better word is at most 3 maximums and minimums. Okay? As a total. And because they're all different zeros, there's no multiplicity there, it actually tells us that we will have 3 turning points. Okay? So we get a lot of information from being able to do this. Does that make sense? Okay? So those last, when you answer that question in WebAssign, when the last part they say find the other 2 zeros, the other 2 zeros are the zeros that come from 2x plus 1 and x minus 5. And the only way you can get those is if you actually factor, you show me that negative 1 and positive 3 are indeed zeros. Okay? Does that kind of make sense? Now, what's nice about this problem is that they give you kind of these values, right? They give you a head start. Okay? And you might be thinking, well, if I'm going to do this in real life and apply this somewhere else, maybe in a calculus course or something, are they going to give me those values? And the answer is no. Okay? So today's stuff is, how do I determine these C values? How do I determine these ones that are going to give me these zeros? Just real quick, what could I do to see if this is right? What could I do with that to figure out if that is still my polynomial P of x? Careful. We just factored it. What's the inverse of factoring? Multiplying, right? Foiling, okay? So we could take that, we could FOIL it, okay? Now you would FOIL the first 2, right? You would FOIL the last 2, or really just take any 2 that you want to and FOIL them. But then that's going to give you a trinomial times a trinomial, right? And then you use the distributive property to get back to what you started with. Now that's a problem, right? That's kind of tedious. If you, hopefully maybe some of you have downloaded GeoGebra, okay? It's free, okay? GeoGebra.org. But if you go to GeoGebra, go to View and go down to CAS, okay? And this is much more powerful than your calculator. Your calculator can't multiply those out, okay? This is an algebra solving system, okay? And I can type in the phrase expand, and it asks for an expression, so I'm going to type in, we had x minus 5, what was it, x, was it minus 3? There's plus 3? And then x, was it plus 1, and 2x plus 1, and I ask it to expand that, and we get back then to the original polynomial that we started with, right? Okay. Might be a tool for you to check whether you're doing this stuff correctly or not. All right. The next question that I want to talk about